In this example, we want to show that the triangle inequality holds as a strict inequality and as a strict equality for the infinity norm. We want to find situations where this is true. Okay, so the first example, I'm gonna try to see where we can find this as an equality. So I want the infinity norm of x plus y to equal the infinity norm of x plus the infinity norm of y. Okay, so if I'm looking for an example where this is equal, what I want is when I add them, the biggest number is still the biggest number here plus the biggest number there. So if I take something like x equals, let's say, 0, 1, and y equals, let's say, something like 1, 3, because the first component here is the largest and the second component here is the largest and the second component here is the largest, then our x plus y is going to have the largest second component. So when I add them, the infinity norm is going to be the second component. The infinity norm of x is going to be the second component. The infinity norm of y is going to be the second component. So the infinity norm for x plus y is the largest component in x plus y. So that's 4. The infinity norm for x plus the infinity norm for y, the largest component in x is 1. The largest component in y is the 3, which gives us a 4. And so this holds as a strict equality. Now, if we're looking for this as a strict inequality, we want x plus y, the infinity norm, to be strictly less than the infinity norm for x plus the infinity norm for y. The best way to do this is when we're constructing our x and our y, don't have the same component in x and y be the largest. So for example, if I take x to be, let's say, 1, 2, and I take y to be, let's say, 3, 5. Oh, that won't work because I have the same largest component. We'll say 13, 5. Okay, so now x plus y, this vector is 13 plus 1 is 14. 5 plus 2 is 7. And so the infinity norm for x plus y, the largest component in this vector, has size 14. The infinity norm for x plus the infinity norm for y is, well, the largest component in x is 2. The largest component in y is the 13. So this gives us 13 plus 2 is 15. And so here, the infinity norm for x plus y is 14. The infinity norm for x plus the infinity norm for y is 15. So indeed, the infinity norm for the sum is less than the sum of the infinity norms. So that is an example that works here. So because you have those two possible situations, the triangle inequality is that for vectors x and y, the absolute value, or the norm of x plus y, is less than or equal to the norm of x plus the norm of y. Right? So you might have the equality case like we had up here. You might have the strict inequality case that we have down there.